The numbers 3, 7, 11, 15, 19, 23, and 27 represents an arithmetic sequence. This would be a geometric sequence: 3, 6, 12, 24, 48, 96, 192. Do you see the difference between these two sequences? And do you see any patterns within them? In the arithmetic sequence on the left, notice that we have a common difference. This is the first term, this is the second term, this is the third, fourth, and fifth term. To go from the first term to the second term, we need to add 4. To go from the second to the third term, we need to add 4. And that is known as the common difference. In a geometric sequence, you don't have a common difference. Rather, you have something that is called the common ratio. To go from the first term to the second term, you need to multiply by 2. To go from the second term to the third term, you need to multiply by 2 again. So that is the R value. That is the common ratio. So in an arithmetic sequence, the pattern is based on addition and subtraction. In a geometric sequence, the pattern is based on multiplication and division. Now, the next thing that we need to talk about is the mean. How to calculate the arithmetic mean and the geometric mean. The arithmetic mean is basically the average of two numbers. It's a plus b divided by 2. So when taking an arithmetic mean of two numbers within an arithmetic sequence, let's say if we were to take the mean of 3 and 11, we would get the middle number in that sequence. In this case, we would get 7. So if you were to add 3 plus 11 and divide by 2, 3 plus 11 is 14. 14 divided by 2 gives you 7. Now let's say if we wanted to find the arithmetic mean between 7 and 23. It's going to give us the middle number of that sequence, which is 15. So if you were to add up 7 plus 23 divided by 2, 7 plus 23 is 30. 30 divided by 2 is 15. So that's how you can calculate the arithmetic mean. And that's how you can identify it within an arithmetic sequence. The geometric mean is the square root of a times b. So let's say if we want to find the geometric mean between 3 and 6, it's going to give us the middle number of the sequence, which is, if we were to find the geometric mean between 3 and 12, we will get the middle number of that sequence, which is 6. So in this case, a is 3. 3 times 12 is 36. The square root of 36 is 6. Now let's try another example. Let's find the geometric mean between 6 and 96. This should give us the middle number, 24. Now we need to simplify this radical. 96 is 6 times 16. 6 times 6 is 36. The square root of 36 is 6. The square root of 16 is 4. So we have 6 times 4, which is 24. So as you can see, the geometric mean of two numbers within a geometric sequence will give us the middle number in between those two numbers in that sequence. Now let's clear away a few things. The formula that we need to find the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times the common difference d. In a geometric sequence, it's a sub n is equal to a1 times r raised to the n minus 1. Now, let's use that equation to get the fifth term in the arithmetic sequence. So that's going to be a sub 5. A sub 1 is the first term, which is 3. N is 5, since we're looking for the fifth term. The common difference is 4 in this problem. 5 minus 1 is 4. 4 times 4 is 16. 3 plus 16 is 19. So this formula gives you any term in the sequence. You could find the 5th term, the 7th term, the 100th term, and so forth. Now, in a geometric sequence, we could use this formula. So let's calculate the 6th term of the geometric